Unit 3, Day 3 notes. Today we're going to be talking about proving lines are parallel. Last class we talked about how the angle pairs were either congruent or supplementary. So to recap, the following four angle pairs are congruent, and they are vertical, corresponding, alternate interior, and alternate exterior. And the following angle pairs are supplementary, meaning adding to 180. And those are consecutive interior and linear pairs. So the new friends that we've talked about this week, the alternate exterior, alternate interior, consecutive, and corresponding, will only be those respective measures, either congruent or supplementary, if the lines are parallel. So if the lines aren't parallel, then you can't say that those things are true. So on number one, we know that the angle 1 is congruent with angle 5, because that's what that little equal sign with the fancy squiggly means. But we have to prove that the lines are parallel. So let's look at where they're placed. Here's angle 1, here's angle 5. Angle 1 and angle 5 are corresponding angles. The reason they're corresponding is because they're on the same side of T, which is the transversal, and they're in the same position. They're both above the parallel lines, or the lines that are assumed to be parallel. So since they're on the same side in the same position, they're corresponding, and because of the converse of the corresponding angle postulate, D, we can justify that line M is parallel with line N. Now, it says the measure of angle 3 and angle 5 add together to become 180. So here's 3 and 5 again. So those are consecutive interior. Consecutive interior because they're on the same side of T and they're both inside. So since they're consecutive interior angles, they're supplementary, and that the converse of that theorem is justification for why M and N are parallel. So that's B. Given angle 3 is congruent with angle 6, so here's 3 again, here's 6. Which postulate or theorem justifies that M is parallel with N? So now when I look at the placement of 3 and 6 together, they're related because they are alternate interior angles. They're alternate interior angles because they're on opposite sides of the transversal, and they're both inside the two lines. So based off the alternate interior angles converse, which is C, we can say that M is parallel with N. Measure of angle 4 and angle 6, so here's 4 and there's 6 again, equals 180. Why are they 180? Because they're supplementary. And why are they supplementary? Because they are consecutive interior angles. And since they are consecutive interior angles, they're supplementary. So that proves that M is parallel with N. So B, consecutive interior angles. Converse. So on this example, we're going to prove whether or not a pair of lines is parallel based off of one of the four theorems or postulates. I'm going to letter them because having to write it out, my handwriting is going to look horrible. But you all are writing by hand with pencil and paper or pen and paper, so please write it out. Okay? So if I look at angle 1 and 3, here's 1 and there's 3. In respect to lines C and D here, those two angles will be in corresponding positions. They're corresponding because they're on the same side of line A in the same position. So since 1 and 3 are corresponding angles, that's why they're congruent, and that would prove that line C and line D are parallel. So C is parallel with D because of the D, converse of corresponding angles postulate. Now the next one says that angle 5 is supplementary with angle 9 because they add to 180. When I look at angle 5 and angle 9, the line that ties them together is line C. So line C would be the transversal possibility, and they're between A and B. So if they're between A and B but on the same side, they're consecutive. So yes, that would be true that they would be supplementary, and that would make A and B parallel because of the consecutive interior angles converse. Which is what I call B. Now angle 11 and angle 16 are here and here. Now angle 11 and angle 16 is a vertical pair. So but just simply being vertical will mean that you're going to be congruent no matter what. It doesn't matter if the lines are parallel or not. Just simply because they are vertical or bow tie angles is the fact that they're congruent. So it does not prove that any pair of lines, A and B or C or D, are parallel. All right, angle 13 here and angle 12. So the line that would be the transversal in that situation would be line B. And so we're trying to prove that C and D are parallel. Well, 13 and 12 are alternate exteriors because they're on opposite sides of B and outside of C and D. So since they're alternate exterior, they are congruent, and that proves that line C is parallel with line D. Because of the alternate exterior converse, or what I called A. Angle 7 and angle 3. I'm out of highlighter choices. So back to my pen tool. Angle 7 and angle 3 are a linear pair. So since it's a linear pair, it automatically is supplementary because they form a line. And again, it doesn't matter if the lines are parallel. Every linear pair is supplementary. So we don't have proof that A and B or C and D are parallel. And last but not least, we're going to talk about angle 10 and angle 11. Now, angle 11 and 10 are on the same side of B, and they're both inside of C and D. So it appears that they are consecutive. Same side, same side, inside. So because they're consecutive, that does prove that C and D are parallel because of the consecutive interior angles converse, or B in my case. Now, here's a series of lines. They look like they're parallel, but looks can be deceiving. So to prove that they're parallel, we need to see which angles are congruent and which angles are supplementary. So what I would do if I were you is go ahead and find all the congruent angles first. So this 115 up here would be congruent with this angle across because of the vertical angles. 130 would also be 130 here. 80 would be down here because of vertical angles. 65 here because of vertical angles, and 45 here because of vertical angles. And now you could do their supplements as well and fill them in. So the supplement of 115 is 65. So that means the one across from 65, the vertical pair, is here. The supplement of 130 is 50. So the bow tie would be here, 50 as well. The supplement of 80 is 100. So that means this is also 100. The supplement of 65 we mentioned before was 115. So this is also 115. So the supplement of 45 is 135. And this bow tie would also be 135. So it seems that 65 and 115 repeated itself. So let's go back and highlight those so that they stand out. So here's 65 first, and here it is again repeating itself. So if things are correct, F is the transversal, and line A, and line D might possibly be parallel. So let's verify. 65, the first 65 up top, and the second one down below are considered corresponding if you kind of eliminate B and C being in the middle. You would see if those were not existing, 65 corresponds because they're both left of F and above the lines A and D. So since those are corresponding, that would imply that line A is parallel with line D. Line A is parallel with line D. And those are the only pair of parallel lines. This concludes your notes for today.